chapter number 3, force and pressure of physics. Okay, so already we have seen many topics in this force and pressure. So force part has been finished. Okay, means, or I can say what topic was related to force we have seen: balanced, unbalanced force, contact, non-contact force, types of forces. Okay, then inertia we have seen. Now we are going to see another topic, that is pressure. Okay, you know that we apply pressure like vehicles of your car, sorry, tires of your vehicles or cars. You know that we are putting air in that tires. So actually what we are doing, pressure. Okay, we are filling air in the tire, and if you see that meter where we are taking our vehicles to fill air in the tires of our vehicles, that is air filling machine, pressure. Okay, which is indicating the dial also of pressure only. If you'll see, air pressure is written. If you go to petrol pump, you will see one box like air pressure is written. So pressure we are putting, or just take an example of your bicycle, children, by hand pump. Okay, by hand pump, what you are doing, you are applying force, you are applying pressure. Okay, so that means the pressure is depending on force. Pressure is depending on force. Let us see how. Okay, so what is the relation between pressure and force? Okay, now just we'll take one example of nail and hammer. Okay, so imagine this is the nail, this is its sharp part, and this is blunt portion of the nail. Okay, I am repeating. Imagine this is nail and this is sharp part of your nail and this is blunt. Okay, now how you are hammering, or how you are putting this sharp towards the wall, sharp end is toward the wall, and on this blunt surface we are hammering. Correct? We are striking the hammer on the blunt. Okay, now what I did, I am hitting. I am hitting means what? This is the action which represent that I am applying force on this particular. Now see, if I apply less force, what will happen? Less part of the nail will go inside the wall. If I hammer it with more force, more the nail will go inside. So I can say pressure is directly proportional to force. Means as I am applying more force, more pressure on this tip of the nail, and it will go inside. What is the effect that it is going inside after application of hitting, hammering? Okay, so the nail will go inside. So I can say if I increase the force, it will, more pressure will be applied. If I decrease the force, pressure will be decreased, it will less go inside the wall. So pressure is depending on force. And how is it depending? It is depending that as force is increasing, pressure is increasing. Force is decreasing, pressure is also decreasing. So I can say it is directly proportional. Depending on, directly proportional. Value of force increases, pressure also increases. Value of force decreases, pressure also decreases. On what another thing that pressure is depending, let us check out, children. Now this is pointed area of the nail and this is blunt surface. What I did, instead of keeping sharp part or pointed part, I'll just place it blunt surface near on the wall, blunt surface on the wall, and sharp near the hammer side where I am going to hammer. What if I hammer, what will happen? The nail will not go inside, means, and if I put this or if I keep this sharp portion towards the wall, so what is the difference between blunt surface and the sharp portion? That the sharp portion is having less area and the blunt surface is having more area. So I can say that pressure is depending on area. But how it is depending? That sharp area and blunt area, what is the difference? Sharp area means area is less and blunt side will have area more as compared to this sharp. Okay, so I can say that if area is increasing, pressure is decreasing. Just now you have seen that sharp area of the nail will go very quickly inside, but as compared to this I will require more force. Okay, so area and pressure is having inversely proportionality. Inversely means area is increasing, pressure is decreasing. If area is decreasing, pressure is increasing. So I can say that pressure is directly proportional to force and inversely proportional to area. If we remove proportionality sign, pressure is equal to force upon area. Proportionality, pressure is equal to force upon area. Just consider proportionality sign is K and K is equal to 1. Okay. So pressure is equal to force upon area. How we represent pressure? By capital P. How we represent force? By capital F. And how we represent area? By capital A. So what is its formula? Pressure is equal to force upon area. Okay. So let us see its SI unit. SI unit of pressure is equal to, okay, what is unit for force? Newton. And what is unit for area? Meter square. Okay, so unit for pressure is Newton per meter square or Pascal. Pascal is the name of the scientist, Pascal. Okay, so instead of taking only one small p, we take PA because already for pressure we represent it by P. So if this also if we represent by P, like Newton capital N, Pascal capital P, P will get confused. So hence we are using PA, Pascal here. Okay. So this is SI unit for, either you may write Newton per meter square or Pascal. Suppose I am saying 25 Newton per meter square. So what does it mean? This is pressure. Or only write 25 Pascal. Still it is what? The same. That means 1 Pascal is equal to 1 Newton per meter square. 1 Newton per meter square means 1 Pascal is how much? 1 Pascal is when we apply 1 Newton of force on area 1 meter square, then the pressure is said to be 1 Pascal. I will repeat. If define Pascal or define 1 Pascal, when force of 1 Newton is applied on area 1 meter square, then the pressure is said to be 1 Pascal. Pressure is Pascal, force unit is Newton and area's unit is meter square. Hence, pressure 1 Pascal is force when we apply force of 1 Newton on area 1 meter square. Means only on 1 meter square area. If we apply force of 1 Newton, then how much pressure is there? 1 Pascal. It gives you idea about Pascal. Now let us see in our day-to-day life where we can see pressure or how we will use the definition of Pascal or formula for Pascal. Now you know this, we need to apply more force to get more pressure, or we need to decrease the area to get more pressure. Now you know that in your day-to-day life you have seen many of the examples. Take an example of knife. Okay, Which side you use? Knife, sharp side or blunt side? Sharp, because there are two portion in many of the knife. We are having both portion. This is one is blunt part and this is sharp part. So which area you use? This sharp, not this blunt area. Why? If you try to cut by blunt area, what will happen? The fruit or vegetables will not cut easily. Why? Because it depends on area. If we decrease the area,